Hi, Stu Schwartz, MasterMathMentor.com. This is video AB29A. The topic is Riemann sums, and it covers the AB manual pages 175 through 177. Suppose you were asked to find the sum of the first 5 terms of 1 plus 2 plus 4 plus ... Write it down. Did you write 31? Did you write 25? Each answer makes sense. The 31 comes from 1 plus 2 plus 4 plus 8 plus 16, where each term is doubled the previous term, and we end up with 31. 25 also makes sense. The difference between the terms 1, 2, 4, 7, and 11 are 1, 2, 3, and 4, and that gives 25. Which is right? The problem is the use of the ellipsis ... That means to continue the established pattern. But with only 3 terms, it is very difficult to figure out what that pattern really is. We need more terms. And even if we had more terms, the pattern is not always obvious. We need a better way to describe this problem. So we introduce the Greek letter sigma, which means sum. We will now use sigma notation to describe the problems that you see above. The sum of n terms, a1 plus a2 plus a3 plus ... plus an, is written sigma I equals 1 to n of ai, where I is the index of summation and ai is the ith term of the sum. Sigma notation is a precise way to write a sum, but does not actually help to compute the sum. So sigma I equals 1 to 8 of 3 means 3 plus 3 plus 3 plus ... plus 3, where we have 8 3's, and the sum is 24. Sigma I equals 1 to 6 of I means 1 plus 2 plus 3 plus 4 plus 5 plus 6, and the sum is 21. Sigma j equals 1 to 7 of j squared is 1 plus 4 plus 9 plus ... plus 49. This is the sum of the squares of the numbers from 1 to 7, and our answer is 140. Sigma k equals negative 2 to 3 of k cubed is negative 8 minus 1 plus 0 plus 1 plus 8 plus 27, and the answer is 27. This is the sum of the cubes of the integers from negative 2 to 3. Since sigma I equals 1 to n of ai represents a summation of numbers, we can apply basic properties of addition and subtraction. So sigma I equals 1 to n of k a sub I equals k sigma I equals 1 to n of a sub I. You can simply factor out the k. And sigma I equals 1 to n of a sub I plus or minus b sub I will equal sigma I equals 1 to n of a sub I plus or minus sigma I equals 1 to n of b sub I, where we write one sum as 2 sums. So number 5 reads summation I equals 1 to 7 of 8i, and that can be written as 8 sigma I equals 1 to 7 of I, and that will be 8 times the quantity 1 plus 2 plus 3 plus ... plus 7, and that gives 224. Number 6 reads summation I equals 1 to n of 5i minus 2. We can do several things here. We can first factor out the 5 and write as 5 sigma I equals 1 to 9 of I minus sigma I equals 1 to 9 of 2. So the first sum is 5 times the quantity 1 plus 2 plus dot 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 plus 9. And the second is 2 plus 2 plus 2, and there are 9 2's. So we end up with the answer 207. Number 7 reads sigma I equals 1 to 6, negative 1 to the I plus 1 times the quantity 2I squared minus 1. Negative 1 to the I plus 1 is a way of creating the signs being first positive, then negative. When I is 1, I plus 1 is 2, and we have negative 1 squared, which will be a positive. When I is 2, 2 plus 1 is 3, and negative 1 cubed is a negative. So the signs alternate. The numbers are 1, 7, 17, 31, 49, and 71. So 1 minus 7 plus 17 minus 31 plus 49 minus 71 is negative 42. Number 8 reads sigma I equals 1 to 9 of negative 1 to the I times I all over I plus 1. Negative 1 to the I also alternates the signs, but the first one will be negative and the second is positive. I over I plus 1 is 1/2, then 2/3, then 3/4, etc. So we have negative 1/2 plus 2/3 minus 3/4, and ending with negative 9 over 10. And the answer is negative 0.646. There are several formulas that we use that are helpful in adding many terms. The first formula says the sigma I equals 1 to n of k, which is k plus dot 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 plus k, is simply k times n. Second formula, sigma I equals 1 to n of I, which is 1 plus 2 plus dot 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 plus n, can be written as n times n plus 1 over 2. The summation I equals 1 to n of I squared, which is the sum of the squares of the first n terms, which is 1 squared plus 2 squared plus dot 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 plus n squared, can be written as n times n plus 1 times 2n plus 1 all over 6. And finally, sigma I equals 1 to n of I cubed, which is the sum of the cubes of the first n numbers, is 1 cubed plus sec2 cubed plus dot 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 plus n cubed, and that can be written as n squared times n plus 1 quantity squared all over 4. Sigma I equals 1 to 100 of I is the sum of the numbers 1 plus 2 plus 3 plus dot 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 plus 100. There's no way we're going to add up 100 integers, but we can use our formula that says that this will be 100 times 101 over 2, which is 5,050. Summation I equals 1 to 30 of I squared is the sum of the squares of the first 30 integers, which is 1 squared plus 2 squared plus 3 squared plus dot 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 plus 30 squared. And by our square formula, that is 30 times 31 times 61 all over 6, or 9,455. Number 11, sigma I equals 1 to 50 of 2i squared minus 1, which is 1 plus 7 plus 17 plus dot 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 plus 4,999, can be simplified to 2 sigma I equals 1 to 50 of I squared minus sigma I equals 1 to 50 of 1. Utilizing our I squared formula, we get 2 times 50 times 51 times 101 over 6. And using our constant formula, we subtract 50 times 1, and our answer is 85,800. And finally, 12, I equals 1 to 20 of I cubed minus 1 is 0 plus 6 plus 24 plus dot 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 plus 7,980. We can simplify this by writing this as I equals 1 to 20 of I cubed minus sigma I equals 1 to 20 of I. Our I cubed formula will be 20 squared times 21 squared all over 4. Our I formula is 20 times 21 over 2. Do the math and we get 43,890.